All right. Good evening, everybody. So, finished lesson 2. We finished the concepts if, else, if, and else. And now we're moving on to loops. A couple things about before we learn loops. There were some things engineered to support loops. One is a list, an object type of a list, and the other one is a range. I'm going to discuss those really quickly. So, what is a list? Well, there's a couple different ways you can make one. You can see by my screen. I'm just going to go ahead and grab this. Cut and paste it in the shell, hit enter, and grab empty list, which is our variable, holding a new empty list. And let's do a type on it. And we'll see that class is a list. So knowing this, that a list is a type of an object known inside of Python. It's a more complex object. It's a object of objects. Cool. Well, what's so special about it? Well, you could change it, alter it. So that term is called mutable. And then within the object of objects, you could go through them or iterate. Start at 0, the first object, the indice of 0, and then go through your list accordingly. Or you could bounce around your list or a list of lists, or check if something is in your list or not in your list, which is pretty handy too. If you had 100 usernames, you cut and paste them, through them in a quick list, and you just say, hey, is host number 4 in the list? Comes back true or false, you know you're good to go, right? You know it's available. So keep that in mind. There's a way to make an empty list. Also, cool thing about a string is if we were to call in the list function and pass it a string between quotes, store it in list string, right? What list function does to it is it creates an object of objects. So it'll take each character in your word and put it in an indice. So H is in 0, E is in 1, and so on and so forth. Now you can do cool stuff like this. You could say if E in list underscore string print, we'll just say, yep, E is in there. Well, guess what? Yep, E is in there. So now we could use comparison operators and if, else statements like we learned in lesson 2, along with lists, which just add to your arsenal and add to your combinations of potential logic you can create. Just pretty helpful. A list can be a list of lists. We proved that here. Well, actually, this is a list with a tuple. A tuple is another type of object, except you don't declare it with list. You can simply say my tuple equals, and then just put in parentheses, I think. Let's see this new type of MIT. And it's a similar object to a list. You can iterate through it. It's an object of objects, but a tuple or a tuple is immutable, so it shouldn't be changed or altered. Or we'll see about that later on when we talk about them in our lesson. But you can create an empty list a couple ways. Call on it by a list function, or you can call on it with open close brackets. We could create an empty list here. Elist equals open close brackets, hit enter, and we call on our empty list, and you see it is indeed an empty list. Cool. List can be made of mix objects. So here we have a list of mix objects. You guessed it, no problem. It'll do it. And here's our in and not ins, very similar to what I did before with the if statement. This is just doing it in one line. If you had an elif or else, you could do that as well. Append. So append is a method of the list class object type. So certain object types that are classes have functions. Those functions are called methods to that type of object. So one is append. So let's take our empty list and let's add, we'll call it our empty list, and we'll append 5 to it. We'll hit enter, call on EL. Now 5's in our list. Well, what if we added A to it? You guessed it, A's in our list. So what does append do? The answer's in the name. It applies to the end. So whatever you append to your list, it will be in the next indice over. So we have 0, 1, and if we do it again, it'll be in 2. Fun stuff. And we can also add lists. So let's do that. Let's call it our empty list. Let's append. Let's pass another list object to 6, 7. Hit enter, call on append, or our list. And you see that it has our original 2 objects added along with our third object, which has 2 of its own. Cool. And here walks in pop. Pop is a unique and fun method of a list object. I suggest if you pop an object out of a list, you store it somewhere. So we'll say P1 for, let's say item 1. Item 1 equals list, and we're going to pop an object. We're not going to declare anything in pop. That means it's going to take the last item in your object. I'm going to hit enter. I'm going to call on my item 1. Now it has 6, 7. I'm going to call on my list, and you notice that 6, 7 is no longer in that list. It's popped out. And I stored that object in item 1. Item 2, item 3, so on and so forth. You could pop, you can create a variable called last item and pop that item first. You can create an item. Can we pop it? Yeah, we'll get more into pop as the class goes on. And sometimes you want to clear a list. Well, there's a method for that, right? It's perfect. So what if we didn't want this 5 and alpha and EL? EL clear, call on EL, it's an empty list. So now you can go back to reappend it or start from the beginning. All kinds of fun stuff. So here we have a list string, list hello, we already did that. It breaks it out into each character. Min, max, and sorted. These are functions that work with the list object. So let's create a quick list called my list. It'll have it equal 1, 2, 6, 4, 3, 5. That's fine, right? And we'll call on my list. Well, before we do that, let's call on min and pass it the parameter of my or argument of my list. Gotta spell it right. And you see it gives us 1. Well, it has the lowest integer value. Strings would be a bit different. Max, my list, 6. Yeah, that stands true. Now, you can also do sum of your list. Now, my list sum, there's a trick here. It has to be similar object types. So if this was a list of integers and strings, this would fail. But since it's all integers, it sums up just fine. So that's pretty handy too, right? You can sum a list really quickly. And then, let's see, my list is messed up. Let's do S my list. So we'll sort my list, and that will equal sorted and pass it my list. And then we'll call on sorted my list, and you see now that it's sorted numerically. Excellent. Yeah, reverse is pretty handy. It's kind of cool too. So let's do it to the one we just sorted. Let's call sort my list and reverse it. Hit enter, sort my list, hit enter, and you see it just does that. It reverses it. Super handy. Well, that's lists in a nutshell. Some fun things. There's some more videos in the class where I go into a bit deeper in lists, but they're really, why are we discussing them, right? Well, for loops love lists. Like you could say for each item in sort my list. Oop, I messed it up. Then you can just say print item. Oh, I messed it up again. It's one of those days. So now here you can say for each item in my list of items, print the item, or for each integer in my list of integers, print the integer. You notice the for loop stops when it runs out of objects. It's a beautiful thing with lists in Python. Awesome to know, right? Well, we also have a range function. So range is kind of unique. Range generates a sequence of integers when you don't have one already. So let's just take a look at range right off the rip here. 91 lines of help. Built in, it's a class of a range object. Okay, so it's its own object. It has a start, stop, and a step if you use all three arguments. Okay, some more stuff, tons of stuff about it. Cargs, args, we'll talk about those at a later date, what these are, quargs and args. But start, stop, step. Well, what does that mean, really? Well, let's say my range equals range of, I'll spell it right, it's the important thing. Let's start at -1, stop at 6, and we'll count by 1, which is the default positive. So I hit enter, and then we take a look at my range, and well, it says 1 through 6 range. Cool. What's so special about this? Well, for each item in my range, print item. Now you have your -1, 0, all the way to 5. Start at -1, stop at 6. So you're going to have everything before 6. Cool. Well, let's take my range again, and let's give it a step by. And let's step by 2, 2 positive. Let's do the same for loop. For each item in my range, print the item. Well, now it's -1, counting 2, stepping by 2, 1, plus 2, 3, 2, 5. Super cool, super handy. Range was almost engineered for a for loop, right? I can do all kinds of fun stuff like that. This one kind of comes into play pretty good. Get rid of this for now. So in this example, we have a list of devices, and then we throw the length of devices. Length is another function for a list. It'll count the total items in your list. So right here, let me go back to this, and let's see, do we still have my list loaded? My list loaded. If we do the length of my list, it would tell me I have 6 items in that. You're right, the length is 6 objects. So here we get the length of devices. Then we have a range where we start at 1, we stop at the length of devices, and we count by 2. Okay. And then we say for each item in my range of my length of devices, print the item. So this will just be integers, right? Save F5. And here we have 1, right? 0, start at 1. So it missed this one, went to 1, goes to the length of devices, counts by 2, and gets 3. 0, 1, 2, 3, start at 1, count by 2, end. Done. Pretty cool. You can also flip this around to where you print the device name and all kinds of handy stuff, right? So let me get rid of this. We'll just keep going. So this is a fun one. This is for each item in my range of 5, print the I. We've done something similar by using range in a variable, but you could use it, this is in line. So we just grab this, just throw it over here. For each item in my range of 5, print I. And now you have your starting at 0, stepping by 1, stopping before 5. You still have your 5 objects because 0 through 4, 0, 1, 2, 3, 4 is 5 objects. Pretty handy. You get pretty tricky with this though. Let's see, similar to slice function, start and stop and step. Let's see where we want to go here. We already we'll talk about start, stop, and step. That's no fun. And if so, we can always cover it next week or a different video. Oops. There's some other videos within your coursework too that cover this material in detail. There's some different examples. And here we have a my list, a mixed list, right, with different types of items in it. And here we're using everything we learned currently and last week, right, and in lesson 1. So for each item in my list, if item is not equal to Tim, print the item. So this is to print everything except Tim, right? And there you go. It prints everything except Tim. Item not equal to Tim, print. Works pretty handy, right? And then we walk into, let's discuss some for loops now. For loops, you've seen me use them already. For loops, right here, it executes a block of code for each element. It iterates over some type of iterable object, being a list, a dictionary, a range, a complex object. Even a string is considered a complex object. You like right here is perfect. This is a great example. We'll just run this like this. So what I'm going to show you here is for each character in string, print the character end with a space. So now I'm going to say it doesn't end with the default hard return, it ends with the space, but it prints out each character. Now, if we remove this end, now there you go. It prints them all because default to print is a hard return. So cool stuff, right? You can have a lot of fun with this, get really tricky with it. Let's see, countdown of an element, simple range. You already kind of printed through that, ended with nothing. Tuples do the same thing. They act very similar to lists. You can iterate through them. It's really no big deal. For value in, print value, we'll touch on that again. It's kind of important. Well, it's all important, right? So here, I just did what I didn't want to do. There we go. So for each value in my list, print the value. So for Ramones fans out there, hey ho, let's go. It'll print each value just like an integer and a range, but you get the gist of it. Now, system automation, things like that. You could say for each computer in my list of computers, ping the computer. If comes back true, send credentials, check if this patch is there. If not, deploy the patch, else update the spreadsheet that it's patched and keep going. So for and ifs are pretty handy in automation for across the board. Let's keep that in mind. I don't want to get too much into dictionaries yet. They're a complex object. I'll talk more about them next week. Let's talk about nested for loops. This is kind of not my favorite, but we'll do it anyway. And you'll see why it's not my favorite. I gotta remove that. Jeez, man, it's one of those days. So you could nest loops just like you could nest if logic, right? So if you had an outer, for outer in range of 2, stopping at 10, so that'd be 2, 3, 4, 5, 6, 7, 8, 9. And for inner in range of 2, stopping at outer, so now this would be range 2 to 2, 2 to 3, 2 to 4, 2 to 5, 2 to 6, 2 to 7. Get the drift there. And then here we try to find the modulo if it's true or false. So if it's divisible by 2, so if it's prime, right? Let's run it. And we'll have 2 is prime, 3 is prime, 4 is not prime. It can be factored. 5 is prime. 6, of course, can be factored. 7 is prime. 9, 8, 9. Really low rent prime number finder, but pretty cool stuff with nested for loops. Now, you could do for each computer in my list of computers and each IP in my list of IPs, perform this task. If computer has IP, make it a pair, else if. You could do all kinds of wild stuff with nested for logic. Now, while loops, I don't use them. Never had to, never needed to, right? Why? Some people like putting while true and then using a break. To me, that's lazy programming because you're going to purposely break your while loop. So why put it there in the beginning? Use something else. Use a for loop if you can, if you know how many objects you have. If you don't, then what do? Well, what's the difference between a for and a while loop? Well, think of it this way. While I have energy, I'm going to do push-ups. Could be an infinite amount. And then when I don't have energy, I break. I quit the loop. Do 10 push-ups. For each number in my 10 push-ups, do a push-up. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I'm done. I'm out of here. The loop breaks itself. Sometimes not everything can fit in a for loop. Let me think. System administration, I've never had to not use a for loop. For each item in my list of users, for each item in my list of computers, for each item in my list of IPs, nothing's ever infinite. So I don't sit there and do a while. I'm trying to think of whether there's a place for them, and honestly, I don't use them. And certain languages, even newer languages, don't even have a while loop because it's kind of broken logic if you think about it. But there's one thing I want to show you before we move on. Where's those triple things at again? I'll do this. Let me get rid of this one. So we have some up here. Where else do we have any? I'll put some right here. And I'll put some right here. So we're going to focus on this. For value and hey ho, let's go. What if we put a counter right here? Counter equals 0. And for every item, I'm going to counter equals counter plus 1. I'm going to show you how to do this a couple different ways. Right? And then when we're done, I'm going to print the counter. Pretty cool. Save F5. Oh, no, what I do? Inconsistent tabs. What does that mean? What I do? That's tabbed over. That's just fine. Print value. Where would this be? Why is this an issue? Anybody know? There we go. We just had a backspace and put a space between here. So now we have for hey in my list, print hey, counter add 1. For for the loop is still going. You notice it didn't print the counter yet. For ho, for let's go, every time it adds 1 to the counter, then I say print counter and I have 3. Cool way to keep a number of how many games you play or how many iterations you run through, how many things were true or false. If you got an if statement here, you could count when things met that operation. You could have 2 counters. You could infinite amount of possibilities with this stuff. Now, another way of writing this is counter plus equals counter and removing that plus 1. Because why would that matter? Will this work really? Counter equals 0. This may not work. Still 0. If counter equals 0 and you go to add counter to itself, 0 plus 0 equals 0. So you're going to have to add 1 to counter. But when? Well, now I can add some logic of if this occurs, add 1. But I showed you the other way how to do that. It just counter equals itself. So what's that term that they use for this? I have to look it up and remember. Right now it's evading me. But you can just add one to counter this way. That's cool. Now, if a counter exists already for counting down, like if counter was 100, you could subtract 1 from 100 and go backwards as well. Change this to a subtraction sign and count down from whatever you want. You could do a lot of fun stuff with counters. There'll be more on that, and there's another video in the classwork as well. Now, while loop, while I have energy, I'm going to do push-ups, do 10 push-ups, 10, 5, 4, 3, 2, 1, right? So while equals 3, while counter is greater than 0, print counting down counter. Counter minus equal itself minus 1. Well, that's the solution, right? That we just did. Instead of counter plus equal counter, it's plus equal 1. I had that backwards. So now when you run it, you still get to 3. This is considered more Pythonic, more elegant, more easier to read than counter equals counter plus 1. Just keep that in mind. But here we're going to remove 1 from counter and basically count down. So counter is going to remove 1, eventually be 0, and while 0 is greater than 0, false, then the logic removes itself from the loop without breaking. I like this. The logic does the work for you. You're not forcibly breaking anything. Makes sense. Let's see, this is never gets printed. Nothing ever happens because counter equals 0, counter's never greater than 0, so nothing ever executes. Keep that in mind as well. Sometimes you may have to add some logic to build your counters. Now here we get into the sloppy stuff of break. Counter equals 0 while 1. While 1 is writing like while true. Print executes at least once. If not counter, break. Okay, we'll see how this goes. Well, it executes at least once. While true. If not counter, well, if not true, break. A lot of crazy logic might not be needed. I'm just saying, it works. It's solid. Python's doing exactly what you told it to. If not true, right, then break. Then you're out of the loop. Cool. I think it's unnecessary. Personal opinion. Now, this is a fun one. Now I have a list of things. And I'm saying while names. So that's like saying while not empty. Print names pop is going. Well, if we remember what pop does, is it removes the last item of the list unless we tell it otherwise. And so this should say Liam is going, Zach is going, it should be done. That's exactly what happens. Handy. Why not use the for loop for each item in names, print item. Print item is going. Either way, have at it. A while or for, I'm a for person, right? But there's nothing wrong with using a while loop. They exist. This gets a little bit more tricky. So we have results. 1, 0, 1, processed, 0, passed equals 0. These are counters. How many items are processed? How many items passed whatever check we're doing? And then it's going to print out while results. So while there's something in this list, processed equals 1, so this counter will go up 1. Maybe not the best place to put it in the beginning of your while. You might want it to happen at your end so you can make sure everything processed, but that's why we have passed. So processed is the result, or process is the item. If it passed the check, it'll add 1 to passed, else it'll continue. Continue does just that. It will continue in the loop until there's no more items or your while result becomes false. Sometimes it's not necessarily helpful, but it's one of those tools that exist in Python to help you out in a pinch if you're not sure if your logic has to continue or not, right? Sometimes you may be handed lists that, or a document or a CSV, a TXT file you won't even open. You might go, hey, what's in here? Well, host names. Cool. They did one column. Yeah, separated by a comma. Thanks. For each get content, fill up a variable from a file and go. But here we go. Process 3, pass 2. So let's see what that means. While results, okay, result equals result pop 1. If not 1, well, if not true, well, that's going to go to past. Add 1 to past. 0. If not false, false, continue. Never makes it to past. If not 1 or true, past. So now we get our 3 process, 2 past, rock and roll. Here's a combination of our if, our else statements out of control, but we could put that right here and tab this over. Same thing will happen. You get the gist of it. But that's while, for loops, range, and lists. Really quick, really dumbed down. Not necessarily dumbed down, but went over pretty quickly. Do your challenges. There's a ton of awesome challenges, and I'll walk you through more of these. There's a couple more videos, like I said, in your course material. If people join tonight, there'll be questions, and I go over more material. But I know it's Valentine's Day, so I hope you're all out having a great time. Other than that, have a great evening, and I'll see you next week.